right. Well, hello everyone. Again, my name is Max. I'll be giving today's lecture on promises. But before we do that, I'm just going to do a brief walkthrough of what we covered last lecture. So we essentially started off with, the concept of asynchronous programming. How do you perform calculations in such a way that you make the most use of, the processing power that's available to you? The straightforward approach would be to just, use synchronous programming, making, requests one after another. And, well, you have the ability to run all of this on one thread, right? So one line of control. But things become a bit more inefficient because in order to send one request, you have to wait for the other one to end up, completing. And this becomes inefficient, especially when these two requests aren't dependent on one another, right? So you can mitigate this by introducing more threads, more processing power. But even though that sort of reduces the number of seconds that you have to, wait for all of your requests to complete, it is still inefficient because instead of, basically doing things the smart way, you're just, throwing more power at it and then just hoping it works. So our solution to this is basically just asynchronous. Having this approach allows you to, especially with streams of data, so when it comes to network requests or, reading files from, your local directory, basically just throwing as many requests as you can at one point, letting all of that delay in, bandwidth transfer occur, and then this opens up gaps that you can actually take to take advantage of by putting more operations inside of those gaps so that you can perform more things while you wait for the responses to come back. And then the best of both worlds is to actually implement asynchronous programming with multiple threads. But for the purpose of this class, we're not worrying about that. One thread is enough for our purposes. So we started with callbacks. This is basically just the concept of passing a function into another function as a parameter, right? To call back a function when you're done with everything else. So in this example, we start with creating a script, right? Setting the source, and this can be a string, file path, URL, whatever works. And then setting two methods for that script. So the first one is onload. Basically, if the script loads successfully, then the callback function will run. And then we use the error first approach by passing null as the first parameter to the callback because there is no error. And then the script as the second parameter because that's what we want to sort of manipulate in the future. Just for the purpose of this callback, we just pass that. And then on error, we do the same, we call the same callback, but instead of passing null as an error, we pass a new error object and then pass nothing for the script because the script wasn't able to be loaded appropriately. So we do all of that, and then we also have to define the callback that we want to use. So that's what we do in this line over here. Essentially just declaring the callback function. In this case, we just want to alert either the error or the script. So if error is null, then you have an optional operator here, an or operator here. So if this is null, then script will essentially be alerted. But if error is not null, then error will be alerted. So alert is a method used for creating pop-ups in your window. So this works. We, in the commented line at the very bottom, we basically call our load script function, pass, a URL, for example, like let's say, CSE264 time.js contains our code that we want to load in. We pass that string, and then we call my callback. So this works, but as your code becomes larger, it becomes harder to maintain because you have to keep track of all these callbacks you're creating. And because of this, the code flows less smoothly, right? Because you have to predefine all of your callbacks before you actually use them, which means that you actually need to know what you want to do with the result before you get the result. So this is where we introduce promises. So prior to 2015, we were using callbacks, and then since then, we basically just use a promise object. So you don't see that here. However, the whole point of it is instead of specifying callback, you can just return a promise object that will fill in, quote unquote, with your value when it's done processing. So this usually applies to, like I mentioned before, streams of data, right? Reading files, making network requests, API requests. For project 0 is due today, right? But project 1 will incorporate making API calls. So you'll be using this in your next assignment. But the whole point is to essentially assign a promise to a variable and then perform all the calculations that you want to. And then when you want the information that is relevant to that variable, you can actually you can access that data and then perform calculations with it later. And what this does, it essentially makes your code a lot more manageable and doesn't lose any functionality in the process. Yep. Sorry? So callbacks were commonly used prior to 2015, but the issue with them is you have to predefine the callbacks before you use them. So you actually need to know what you want to do with the result before you get the result in the first place. And then, if you want to have multiple callbacks, then you have to have more and more parameters. And then you have to predefine all those callbacks, right? So when your code scales in terms of the number of lines of, JavaScript that you have in your files, things become a bit more disorganized, and it just becomes harder to manage, and then harder to debug, and then just harder to work with in general.
So we'll go deeper into that a bit more about the difference between callbacks and promises. That is really key. Like Max said, remember last week we talked a little bit about that callback hell. Having like a callback inside of a callback, inside of another callback. It's really messy, weird, and then code. Of course, there's ways of doing that. But like Max said, when we're using callbacks, you have to be able to specify. You have to say what I'm going to do with this thing before I'm going to actually use it, which is it'd be difficult. Maybe you don't know what to do with this data package. You're asking for some database, and maybe something during runtime you might want to change your mind or do something different, other stuff like that. Another key difference we're going to talk about later about promises is something that promises and callbacks are pretty much interoperable. Any place you can use a callback, you can use a promise and back and forth. They're almost 100% compatible, except for one thing. The one thing that promises can do that callbacks can't is that a single event or a single asynchronous request that a promise generates, multiple things can listen to that. I mean, we can have one promise or one async event signal off to multiple other pieces of code at the same time. We'll talk about that later. You cannot do that with callbacks. Callbacks is like a chain. It goes from one to another to another to another. It's always in sequence with one another. It's always sequential. You want to do a bunch of parallel operations at the same time and condense those at the same thing. You have to use promises. It's an ability that gives you advice.
Yep. Before we move on, does anyone have any other questions?
That's a great question, by the way.
Yep.
That's a really key one.
Okay, great. So how promises work, they are a object in JavaScript that is already available to you, right? So you don't have to install any third-party libraries or anything like that. It's built in. It is constructed with one function, right? We call this the executor or the producing code. This code has two parameters. The first one is a function for resolving a promise and one for rejecting a promise. More about that in a little bit. But basically, in this function, right, you would put anything that you want to work with, like let's say, database call. And then when you retrieve the results for that, you can actually change the state of the promise. And then this will essentially trigger any listeners to this promise to actually execute their code after that promise is resolved. So we'll have a bunch of examples about that. But resolve is used when the job is finished successfully, right? So like if you make a database call and it does return your value and everything's all nice and dandy, right? This is good. If something's wrong with your network and then the request doesn't even go through, and that is cause for an error, so you would probably reject that promise as well. And then you would just do the standard new keyword, just like you would use with creating an object, and then you would pass that function into the promise. And then for the sake of this slide, we declare the function before we use it in the promise, but in all future examples, you will see me putting this code inside of the block, so replacing the promise func with the actual function. So a promise has three states. It starts off as a state of pending with an undefined result. And this is in accordance to how your code should function in general, right? Because when you make a network request, you don't know what's going to happen. When the response comes back, or if it doesn't, then you know whether something went right or wrong. So a pending promise can settle into two other states. The first state would be fulfilled, and then the result would have the value of basically the promise that's resolved, right? You can do this manually, and then a lot of the future libraries that you'll be using with regards to API calls like fetch, those already have promises built in, so you don't have to do any manual promise work with that. But for example, if you use fetch for a URL, then the response from that will be in the result. If there's an error, so anything from you trying to access a variable that isn't defined, that isn't declared, or if there's a network issue, or basically anything that stops the response from coming back in the first place, then this pending promise would settle into a rejected state with the result containing the error that occurred. And then if you want to read more about this, then these slides will be on course site, and then the link over there has a bit more information, maybe an explanation that might be more relevant to how you guys consume information. So moving on from that, we will start off with an example of how promises work. This is a little bit impractical, but it's a little useful in demonstrating how they function. So we start off with creating a new promise, and then in the executor code, we put one console statement, and then we simulate an intensive task by basically using the setTimeout function, which, if you are not familiar with, is basically a function that's used to delay a certain thing by a certain amount of milliseconds. Okay, so we console log hi mom, right, and then we call the setTimeout function for a 1 second delay, and then we resolve it with done. More on that later, but the focus on this is we console log polo, and then after we declare this promise, we console log Marco. So how this works is when you declare the promise, the executor function runs synchronously. So as soon as you declare it, it will run, right? Or as soon as you get to the declared line, when you run it, then it will try to run everything. So it will console log hi mom first, because that's the first line, right? So that you see that out front on the very bottom here. And then it would initiate the timeout, the delay, the 1 second delay. But because there's a 1 second delay, it won't console polo instantly. And then it'll, it's done with the promise, then it moves on to Marco. So that's because that is synchronous code. The second thing that is printed is Marco. And then after a 1 second silence, or approximately 1 second silence, you will see polo. So the order of that would be hi mom, Marco, and polo in that order. Does that make sense to everyone? Sweet. Okay. So just as a summary, right? The function is called executor. It runs immediately by the new promise. It has two arguments, resolve and reject, to change the state of the promise. And then, because they're provided to you by JavaScript, right, you don't actually need to create them. All you have to do is, be able to call them, and then that's it. And then after, a 1 second silence, or in this case, like we're simulating a process, right, we call resolve done, and then it produces the result, and then it sort of, completes the promise in this case. So promises can also be rejected. In all the previous examples, we were just calling resolve. This was under the assumption that everything went well. If something doesn't go well, then we can call the reject function that is already available to us, and then pass an error object into it. So in this case, what we do is we create a promise and then set it to reject with an error after 1 second. Once a promise state settles, you can't change it, so this remains more or less static. It starts off with pending, and then you can only call resolve or reject once. You can call it more times, but it'll all be ignored. So in this example, we resolve with the string done. So done gets put into the result value, value of the promise. And then we also try to reject it after that, and then we try to resolve it after that again. Both of those two extra calls are completely ignored. Does that make sense to everyone? Okay. So at the moment, you might be wondering, well, what do you do with promises, right? Because the way I see it, right, all we are doing is creating a delay, and then we can't do anything with that information. So a benefit of promises is you can actually write code to subscribe to the promise once it resolves or rejects, or once it settles into a certain state. We do that with consuming functions, right? If the executor is the producing function, it produces the result, that the data that you want to work with. And then consuming functions would be functions that want to work with the data that you got in the first place. And these consuming functions would be created with the dot then, dot catch, and dot finally functions. And then we'll have some examples of that right now. So starting off with dot then, how it works is you append it to the end of the promise. So in this example, we just declare a promise, put it into a variable, and then have it resolve with 1, and then try to reject it with an error of 2. How we work with that, and there's a typo because promise should be my promise. Please forgive me. But how dot then works, it is a function that accepts two other functions as parameters. The first parameter is a function that deals with any fulfilled promise values, right? So if the promise resolves, then it would resolve with a certain value, and then that value would be passed into the first function over here. If it rejects, then it would be passed into the second function over here. So that's how dot then works. In this case, we know what this promise will settle as. Can anyone tell me the expected state of this promise once it completes? Will it be fulfilled or rejected? Right, because that's the first thing that we call, and then the second one is completely ignored. So by default, right, because it is resolved, any dot then function that we call will run the first parameter, and the first parameter only. If hypothetically we didn't have the resolve code line and we only just rejected it, then it would go to the second one. Does that make sense to everyone? So this basically builds off of what you did with Project Zero in terms of passing functions as parameters into other functions, which is basically like a callback, right? So we're just doing the same thing here by implementing promises. Yep.
So you're passing error to the then function or the then?
So we are passing two functions into .then. The first one has one parameter of result, which contains the value of the fulfilled promise. So if I look at the state over here, then the first function would accept this value, and then the second function would accept this value. But they're two functions. So it's not like you're passing error into .then. You're passing a function that accepts error into .then. Okay.
Go back to that example. So you're
sure.
Right here, right?
Yeah.
Right there, yeah. So Max is absolutely right. Like you're passing these two functions. Kind of ignore the names and stuff of them. I think they're a little confusing. Imagine that this entire function gets replaced with resolve. When you call resolve, it's like you just called this function. What did I pass? What parameter did I put in resolve? This thing here, this string 1. So my result is 1. It's like this whole function. Imagine this function had a name. This name was also resolve. Like they're the same function. If this one reject, it's the second attribute gets called. This function is the same as this function. What did I pass to this function? Oh, I made a new error. So this parameter inside of here is the error. I'm not actually passing these. It's like I'm calling these functions inside of there. That make a little more sense?
Yeah, so result is like a sub-object of a result, right?
It's a what?
It's like a parameter of a resolve object.
No, they're functions. Just think, remember, like functions are objects, but not subparameters of one another. Just imagine like they become one and the same. Whatever function you put inside the first, parameter dot then, that's what resolve becomes. It's literally like if I gave this function a name called x, I put x and y inside of here. It's like resolve became function x. Now this is x1 or whatever. You know what I mean? If I put a function here and called it y, and reject is called, it's like this reject is now. It's like it's just I said y new error 2. It's like I think it replaced it.
And just building off of that, we resolve with a string value of 1, right? So that would be, that's how you access this. Usually when you're, handling API requests, then you don't know what's coming back. In this example, we do know what's coming back, right? It's either 1 or 2. But so it seems like a little bit impractical to, have, a result parameter because it's going to be 1 regardless. But if this was like a response from an API or a database, then anything in here would be accessible over here, right? And then this error would be accessible over here. Okay, so that's how you basically you put like this value into a variable that you can then use for any operations that you want to do in this function. Does that make sense? Yep. Sorry, could you repeat that?
I try to find a closing brace for the one that's opened in the promise function side. Like wherever
Yeah, that's the typo.
Yeah, you missed that. Yeah.
Yeah, so it would go right over
Right
here.
above the problem. Yeah.
Right below, right before this parentheses. But yeah, you're right. Good catch. Okay. So in our second example, we do the same thing, but just with a delay, right? So we resolve with the string value of done after 1 second. And then in .then, we put two functions, even though we know only one of them will run. So the first one will alert done after 1 second, and the second one doesn't run because the promise resolved with a value. So it is fulfilled. There is no error. This part doesn't run. This part runs. And if we do the same thing with an error, right? If we reject with whoops right after 1 second, then the first function doesn't run, but the second one does. And in this case, right, what we want to do for them is the same. They're both alerts, but we will be alerting an error. If this was switched out with something else, this will still run because it's the second parameter. And then if we know that a promise will only resolve, or if we are only interested in successful completions, right, then we can actually just pass one argument into .then, and because the second argument is undefined, if there is an error, then nothing will happen. And then if there's a successful run, then you will be able to call that singular parameter and then work from there. Are there any questions? Okay. Moving on to .catch. This is very similar, or if not the same as .then, with null passed as the first parameter and then the function passed as the second parameter. So the way catch works is it only runs if there's an error in the promise. So in this case, we have the same example, reject with whoops after 1 second. And then if we do promise that catch alert, it will create an alert pop up in our browser with the error whoops after 1 second. And then how this correlates to how we, what we learned with .then, this is basically like the same thing, if that makes sense, in terms of, doing .catchf being the same thing as .then with the second parameter set as f, because the second parameter of .then runs when you have an error in your promise. So when a promise rejects, for example. And then finally, literally, .finally is similar to .then with both parameters being the same function. Basically, given the context that .finally runs the code regardless of how the promise settles. So once the promise settles, if it's fulfilled or rejected, any code in .finally will run regardless. So in this case, we have a promise, do something with it, and then either resolve it or reject it. If the promise resolves, then you want to, for example, like show a result. If it rejects and you want to show an error, like in your browser, right? And then regardless of what happens, you want to stop the loading indicator because, like for example, when you click a button, it brings up some loading indicator, and then once you sort of render the result or the error, you want to clean it up anyway. So this is useful for cleanup no matter what the outcome is. Does that make sense to everyone? So moving back to slide 3, this is how our code looked with callbacks. Okay, so this is the same code. Basically just predefine a callback function and then use it in the load script and then call load script and then pass my callback as an argument. And how this would look like with a promise is exactly like this. So we basically remove the need for callbacks by creating a new promise object in load script, doing the same thing that we did in our previous examples. And then over here, we call the load script function, and then we add 2 subscribers to this. So once the script is loaded, then you can console log the script, and then if there's an error, then you can do .catch error with alert. And then you can also do, if you don't like .catch, for example, add a second parameter to .then, and then just do the same thing here. Any questions? Okay. So moving on to why we're here in the first place. We have differences between promise and callbacks, and a lot of these were already mentioned. But first and foremost, promises allow us to do things in the natural order. So as you saw with the previous example, we first call a function, and then we do .then, and then .catch. So it all just sort of flows, right? And it's easier to maintain because it provides the illusion that your code is running like line by line, right? And then it's just better code. With callbacks, as mentioned previously, you have to predefine them and pass them as parameters, and then use them in the actual function under a different variable name. Things get really messy really quickly. So, and also like callback hell, and then if you even try to avoid that, then it's still like a bunch of callbacks predefined in maybe not in any necessary order. So because we have to predefine the callbacks, we have to know what we want to do with the result before it's actually available to us. Versus with promise, right? Again, illusion of line by line, so it all flows better. And with callbacks, it can only be one. Versus with promises, you can either chain a bunch of subscriber functions, or you can actually run a bunch of subscriber functions in parallel by just having them reference the original promise in the first place. And we'll move on to that in the next slide. Next slide. But are there any questions so far with regards to this?
So that is just calling the promise function continuously with different parameters, essentially. Or
no? No, not necessarily. No. So the promise runs regardless after you declare it, right? So the promise runs, and then the purpose of .then and .catch and .finally is in those functions you would declare code that you want to run after the promise is settled. So in the promise you would put a request, for example, right? That request takes time to process, time to get sent to the server, time to come back from the server, and then right. So you do that in the promise, and then outside of the promise you would do .then. And then put any code that you want to run after the response comes back from the server. Does that help? So you're not running the promise with different parameters. The promise is already running, and then .then is basically what you want to run after the promise completes. In a sense, yeah.
No, actually not at all. You don't have to know. So What's the in this example of let x equal new promise, pretend it's this promise, and some whatever. We're making a new promise. This x right now, the next line happens. At the moment we create a promise, it's going off and it's doing whatever it's going to do. It's going to take 1 minute or whatever. It takes some amount of time. But it already starts executing. All the code in there is already done. It's going on. It's doing its own thing. Inside of here, at the moment, if I just look inside of it, just say console log x. Remember this says console log. If I look inside of here, I'm just going to say, oh, it's an empty. It's a sentence. You're going to say it's actually you can say type object promise. It's just going to say it's this object. And inside of here is nothing. It's just an empty promise object. There is special. It's part of the promise class, so it has all these prototype methods attached to it. I can add things to it. It's like x dot, q equals 1. It's just an object. I can mess around with it, do whatever I want with it. But it's still empty. There's nothing going on inside of there. And I can still write other code. I can have a bunch of other things going on and do whatever I want. But this promise is running regardless. And when I'm calling callbacks, I have to say inside of here exactly with the moment I make it, the moment I use it, I have to say how I'm going to use it. I have to give it some function f or whatever to tell me back what I'm going to do. With promises, I don't have to tell it ahead of time. I just say run. Just go off and do whatever you need to do. It's going to take 10 minutes. I don't care. And I have my x object. And it's going to be empty. But the only way for me to be able to have some code to say, what do I do when this is done? Well, I tell it. I say, when you are done, when x is finally finished, then do this. Now I'm using it. Now I'm telling it what to do. Then do this. And I say, okay, once this is finished, this is going off to do something. Then do this other thing here. Then do the function q, whatever. Blah 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 blah. Here's a quick question: how do I get the result from here? How do I actually make use of this? So say this thing returned, I don't know, my f, and all this does is like return the number 2. That's it. After I finish all this work, it takes 10 minutes, and I return number 2. How do I get the number 2? How do I add, if I want to add more to that or something like that? Can I just do something like, can I do this? Can I say, I don't know, let n equal x dots n f returns 2 with this work? I'm gonna do something like n plus 5 or whatever. This work? Like this, I can do this. This works. That actually, it'll do something crash. But can I add to that? Is this n actual number 2? Or is it something different? Any guesses?
Something different.
It is something different. Probably why we wouldn't be saying it if it wasn't something different. Yeah.
The result, if it resolves.
Would it be this result here?
Yeah.
So you think n would be like?
No, I'm saying like the value.
So this m is going to be the value 2 because this thing resolved and worked. And I have a function here, and all this function does is return the number 2, right? And it just said it's actually the number 2, not the straight 2, right? So you said m is going to be like the literal number 2. And if I add plus 5 to it, it's going to be 7, right? The value of that. Actually, no. The interesting thing with using promises, once I start using promises, I have to stay using promises. Everything outside of this is not a promise gets wrapped inside of a promise. So this m, I can do this. This let m equals x dot then f return 2. But this m is not the number 2. If I were to look inside of this, do a console log, whatever, and stuff like that, 2. What I'd be getting out of this is promise object, blah, 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 blah. It's also a promise object. Now inside this promise object is the value 2. If I unwrap it, if I have to look inside of it. How would I get the 2 that's locked inside this m? Yeah?
Dot value.
Dot value? Oh, like value of or something like that? Like all objects have that?
No, I'm saying like the resolve, like the property of the resolve, maybe.
It's not really, but you're thinking in the right direction. So if I want to get this, I'd also have to do n dot then. And then have a function inside of here. Also give a function like, console log, or I wanted to add this by 5, right? So like x plus 5 or whatever, add it by 5. Because this m is a promise. I still have the dot then. It's not waiting, right? I'm not like there's no wait here. I'm not waiting 10 minutes for this to return. This happens instantly, right? There's something. I'm not doing anything. But it's also like synchronous because all the other code, this code, everything else outside of here, finished like 10 minutes ago. It's already been done. By the moment we're using promises, we're like way in the future and working on something. Everything already gone. Once you start using promises, you have to stay using promises. And everything that returns from promises, you can do this. This is totally legal. This is fine. The cops are going to get you. But this m is not the value 2. It's a promise. If you want to use the value of it, you still have to do dot then. You have to constantly chain down. That's why if you next you go back to like the previous slide. this. That's why this works. I can do dot then, dot catch, dot blah, 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 stuff like that. I can do this because each successive thing from there is still a promise, right? Just like when I do like on an array, like dot map, dot reduce, dot filter, going that whole chain. I can do that because every time returning back is an array. That makes sense? Kind of, maybe? See some questions? Okay, it'll make more sense if we start programming.
Yeah, we'll have some more examples.
Yeah, we have a bunch more examples.
So, okay. All right. You can move to and from callbacks and promises, right? So you can go from a callback to a promise, and then a promise to a callback. Going from a promise to a callback is, fairly straightforward. You just call the .then function and then pass the function that you want to run as a callback. That's how it works. But going from a callback to a promise is a little bit more involved in the sense that you have to actually, in the callback, create a new promise object and then return that promise object, and then in that actual promise you can fulfill it or reject it, resolve, reject, and then that would essentially convert the callback to a promise because you can access that promise variable after you're done with the initial function. So we can use chaining. So before you would have callback hell, right, where you would have a callback and then another callback, and then things just get unmanageable. And then I lose years off my life when I look at that code. But with promises, you can just chain a bunch of .thens. So .then returns, and this is very important that you guys remember this. .then always returns a promise. If you return something in the function that you pass to .then, it will return that variable wrapped in a promise. So for the purpose of this example, we basically define 3 functions: unresolved, unrejected, and onerror. If we have a resolved promise, then we want to console that result to log, right? Console log, print it to console, and then we want to return the result times 2. If it's rejected, then we just want to console log the error, and then if there's an actual error, then you just want to alert it. Fairly straightforward. What we do is we create a new promise, have it resolve with the value of 1 after 1 second, and then with that we call 3 .then functions. So the first one has 2 parameters, right? As we mentioned previously. We have unresolved and unrejected. So it won't reject in this scenario, but just good program practice. If you're working with API calls, then you want to have something to sort of catch any errors if anything appears. But it would call the unresolved parameter, right, on that function that we declared at the very beginning. So what this would do, it would console log the result, and how it works is because we're using this function, we're able to access the result parameter, right, which in this case is a value of 1. So 1 gets put into result, and then this code runs. So 1 will be printed to console, see that right over here, and then it would try to return 1 times 2, which is 2. But because the code itself is wrapped in .then, it will return a promise of 2. Right? So when you're writing your code and you use .then, and then you try to access it, and then it doesn't work, don't be surprised because it is a promise, not the actual number. Okay. With the second .then, we use the same process. So because it's a promise, you can run .then on this promise. This is what allows the chaining in the first place. Unresolved, or the value of 2 gets put into result, right? You try to print it to console, it would print 2, and then you would return 2 times 2. But because it's in .then, it would return a promise with the value of 4. If we do it again, right? Same process, print 4, because that's what you had in the previous promise, right? Multiply by 2, and then that would return a promise of 8. But we don't do anything with that number, so that gets bin trashed, whatever you want to call it. But as long as you guys understand the mechanics of how this works. So as the professor mentioned previously, once you start using promises, you have to keep using promises. You can't just stop because your code will not work if you try to add 2 to a promise with the value of 4. Okay? And then try to catch an error, and then as mentioned previously, that finally will run this code, which we print completed to console, regardless of what happens to the promise, right? If something fails or if it doesn't, it will be printed anyway. So, and there's a visualization of, there's a graph visualizing this on that moment. But you start with the promise, right? It resolves the value of 1, and after that you run .then, which tries to return 2, right? So it's wrapped in the promise. And we do that again, return promise with the value of 4, and we call the final .then function. Okay.
If like an error happens on like the second, when it's like executing the second .then,
yeah.
Does it just jump like straight to the catch?
Yeah. Yeah.
Like you said, we're not like doing anything with that number anyway.
Yep.
So like if you want to keep it
So we have two options, right? We can keep on using .then, and then, for example, you can do .then, and then if you want to like alert it, then you can, or if you want to render something, render a component in a web page, then you can do .then, like element.inner HTML is the result, and that would change the value like on the actual web page. Or you can actually assign this to a variable and then use async/await, which we will cover in this lecture. Okay.
A question about the previous slide. What is a practical example of going back and forth callback promises?
Yep. So in terms of like going from a promise to a callback, in this scenario, this might allow you to have like more modular code, right? Have like the actual function in another file and just import it. But the focus is on this. So promises were implemented in 2015, right? And we've been using them ever since. But there are still a bunch of JavaScript libraries that are still using callbacks. Okay, so you can either keep on using callbacks in your implementation, or you can convert them to a promise and then have it more compatible with the rest of your code. Right. So like callbacks are like they're not like legacy, but kind of are, right? So we just do this instead. You convert them. Any other questions? Okay. So this is the example that we just covered. This is chaining with .thens running on .thens. So you're sort of like, doing consecutive operations. What we can also do is a more parallel approach where you can have, instead of calling .then on our previous .thens, you can just do promise, which is our declared promise right over here, and then just run .then multiple times on that same promise. And then what that does is essentially, it's the same promise as the previous example. It resolves with the value of 1 after 1 second, and then we run 3 subscribers on that same code. So in this case, like the actual function is the same, but if you want to run different, methods, then you can just have different implementations, and they will each, have different results that you can then access through either more .thens or print them to console or assign them to a variable with async await sort of. Does that make sense? So we can either do, building off of one another, or you can just run in parallel.
Can the .thens from this parallel things ever communicate back to one another again?
So could you?
So in your little tree structure here, with the tree going down, the first .send, regardless of value, could ever share that value with any of the other .sends listening to the same promise?
I would say no, because once you basically like access that result stays in the actual function. It can't really be accessible to other ones unless you were assigned to a variable. But then like you'll deal with a bunch of async nuances that you might not want to.
Yeah, you have to like have like a global variable.
Yeah.
But then you get all the same.
And then you might introduce like a race condition.
Yeah.
It's like so just don't try to do that.
So these aren't compatible. So like the chaining and parallel aren't compatible things. They're different things you use for different use cases. For different things. The first example of going on the chain is more traditional. You're iterating down. You're just iterative programming this and this and this and this and this. But this is something new that promises allow you to do. You can have multiple things listen to the same event and do something different based on that event. And have them kind of happen at the same time. Not really. Remember, it's still a single thread of execution. The actual order of which of those 3 happens is going to change by random chance, just wherever it ends up inside the stack of the call stack itself. But it allows you to do multiple things, but it's that same promise.
Yep. And just like as a practical example, right, just hypothetically using our imagination. Let's say we want to pull user data from a server, right, using an API. That would return a JSON object in most cases. And then what we do with that is you want to display some of that information on the web page. You want to hypothetically update the user information with something else, like the number of times they logged in or how long they've been, like using the platform. And then you want to send that updated information back to the database so that it, updates in the cloud as well. So with the first one, right, with the promise will contain the user data. We would run, unresolved to render the data on the web page. And the second one would update the data with the most recent like counters or whatever, and then also update that in the database as well. And I don't have anything for third. But you get the point, right? Okay. So as of this slide, we covered how we can resolve a promise, how we can reject a promise, right? So that settles the state to either fulfilled or rejected. We covered how to add subscriber functions to the promise, so that would be .then, right? dot catch, and then dot final. So all of these functions, methods that we just covered, are responsible for dealing with an individual promise. Okay, so how do we deal with a bunch of promises? Let's say you want to like send 100 requests to an API, right? You can do it one by one, but that'll take a really long time, and I'll judge you for it. But like the alternative to that is to actually just create a bunch of promises at once, right? Using like a float or whatever, send a ton of requests to the server, and then wait for all those promises to resolve, right? Not one by one, but just like as a bulk. It's like, let me just like execute code, certain code after all of these promises come back. So that is how promise.all deals with everything. So promise.all is a method that's part of the promise object. So you don't. It's not like you create a new promise and then do .all. You would access the actual class and then do that, right? So .all is a method that takes an iterable. In every case in this classroom, it would be an array. So there are like different types of iterables. We're just using arrays in this case. It takes an array of promises, and then how it behaves is it waits for all of these promises to resolve, and then it returns a new promise with the final values. Okay. If any one of these promises rejects, and we'll have an example of that, as soon as one promise rejects, then the whole thing rejects with that value, right? So in this case, it's all or nothing, right? You either get all the information that you're looking for, or you get none of it. So in this example, we have promise.all with an array of 3 promises, 1, 2, and 3 resolved after 3 seconds, 2 seconds, and 1 second respectively. So what that does, it returns a promise, which we can then call .then on again, access the results of these promises, and then it will be, because we started with an array of promises, it will be, values will contain an array with the resolved values inside of it, right? So it would be 1, 2, and 3 after 3 seconds because, for example, the first promise takes the longest to resolve. So if you were doing this one by one, this would take 6 seconds. Because we're doing it all in bulk, it takes 3 seconds. Does that make sense? Okay. So we can move on to promise.all with rejections. In this case, it's the same example, but instead of resolving 2 after 2 seconds, you reject it with an error. So the result of that is, in the previous example, it was an array with 3 variables, with 3 values, but the result for this one is just an error with the dot catch statement again, after 2 seconds. So as mentioned previously, as soon as one promise rejects, the whole thing just goes away, or doesn't go away, but it rejects with the same value that the first promise rejected with. You can also have the promises race each other. That is the .race function. Same example, 3 promises, and then we want to essentially, well, in this case, we want to write the final value, but we can also do console or whatever we want with it. .race returns the resolved value or the rejected value of the first promise that gets settled. So in this case, the first promise resolves in 1 second. This is the fastest promise, so that is what will be returned. Okay. If there was another promise with let's say you resolve 3 after 0.5 seconds, then that would be that promise that is returned. A use case for this would be, I can't think of anything practical at the moment, but let's say you wanted to,
I haven't really either. I've never known why this exists.
Yeah, let's say you have user data in 3 databases that are surrounding you, and you're this is an API for a very important client, and you want to give them the fastest response times you can physically have. So you would send requests to all 3, basically saying I don't care about bandwidth, just the first response that comes back I want to use. That is my impractical.
I'm sure there's something in the official spec of why they go with this.
Yeah, I've never used it, but probably for good reason. Okay, does that make sense to everyone? Sweet. Okay, moving on to async/await. This is where things get exciting, fun. It's your interpretation. You might hate this. I don't know. Functions can be asynchronous. So we have the async keyword for this. How this works is essentially instead of manually creating promises, you can set a function as async, and then anything that you return in that function will automatically have a promise in it. Or if anything that you return in that function will have the value that you return wrapped in a promise. Okay. So per the comment here, async functions always return a promise. We define 2 functions in different ways. The first one is just using the function keyword. The second one is just using an error function. This is the syntax of how you make functions asynchronous in both situations. So the first one you just put async front. and then for the second one you put async right before the parentheses where you have your parameters. So the first one returns 1, second one returns 2. Nice and dandy. If you try to run these functions and print them to console or assign them to a variable, you will get a promise with the value of 1 and a promise with the value of 2. So this is something that you also have to really pay attention to, because if you're using an async function and then returning something and then accessing it through just trying to access the variable without using await, you will be in for some confusion because your code won't work. So we covered this, right? Return the promise. But the benefits of promises is you can also use .then and access them inside of it. So in this case, we do f1 .then num console log num. So this would return 1 because our value here contains 1, and then this one contains 2. We had a question earlier in the lectures of essentially like, okay, like how do you pull the value from the promise and then use it later on? Okay, so that's what we use await for. In this example, we have a promise that resolves with done after 1 second. Okay. How we put that into a variable is declare the variable and then use await promise. So what that does is basically if in this function, right, and in this function only, it will not run any of the future code until this is resolved. Okay. So there are things happening behind the scenes. If you have other functions running, they're still like doing all their things. But like in this specific function, it is waiting for this to resolve before running everything else. So basically this is like taking .then and then applying it on like the function level, I guess. It basically removes the need for using .then as a promise, like in your promise in your code. So we just do result equals await promise, and then if we console log result, we will get our string value of done in the variable that you can then use for anything that you want. Okay. One thing that you need to know is you can only use await if your function is asynchronous. So you have to have this keyword inside of it or you can use await.
That makes sense. It's really clear, but it's inside the await function, not with, or the inside the async function, not outside the async function. Yep. Just because you have a function called async, you can't await outside of that. It has to be always inside of it. Actually, there's some implementation that's trying to do something weird, but I don't think it's officially part of JavaScript yet anyway.
Yep. Yep. So like there's a beta going on in like Node.js and maybe some browsers where you can use top level await, basically like using await outside of an async function, but that is still in beta, right? Testing. We are not going to use it. Okay. Does everyone understand how this works? Any questions, comments, concerns?
It's basically syntactic sugar. So
yep.
there's no difference between doing await and async and just using regular promises and .then and also. The async keyword allows you to transform any function and wrap it as a promise. So I can do new promise, blah, 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 whatever. And await is just like doing .then, but it looks a little bit more natural. It acts more like you would expect when you're using regular programming language and stuff like that. It feels more natural. You're still using promises. There's no different than doing a .then. It's just syntactic sugar. I guess the only other difference is you can't parallel automate waits, right? You can't have like multiple in the same promise.
Then you would have to use promise.all.
Yeah, you use promise.all, right?
Yeah.
You can't do those awaits. Though you could do an await on top of a promise. You do
yeah, await promise.all.
And await on top from that. You can do that.
Yep.
And I believe change the value in an await, like you said, how with .then, like we could do like that at x like +2 or whatever. Like when we do that with await too, like change the value like inside the promise.
In here you can, because that's just the actual value, right? We'll go through it.
Yeah, I mean, like if this result is the value of 1, right? Just like in our previous example, result would be 1, and then you would do const result equals to await promise, which result would be 1, and then after that you can do whatever you want. Add 2, multiply by 2, subtract -1,000,000. It's up to you.
It just it feels like it's still a promise, but it acts more like an actual value. So it acts more like the actual number to the wrap promise.
We'll get to that next
Oh yeah,
time.
actually there's another one for that, yeah.
Okay. Moving on. So because we're using await and not specific promises, we can use our regular try-catch statements for error handling. So this is just like in Java, I believe, right? Basically, have your statements, put all of your await, functions or calls, whatever you want, in the statement, and then the catch block will essentially catch errors from both of these statements. So anything that's inside the try block, if there's an error anywhere in that block, then you can catch it and then perform some error handling with it, whatever works. Does that make sense?
Pretty standard try-catch errors. You can use the same try-catch syntax that JavaScript already provided for you. Yep. It works with automatically. And then equivalent to finally. for
Yeah,
Android?
JavaScript has finally, I think.
Oh, does it? Oh, that's right. That's right. Right. It's one of the keywords. Right.
Yeah.
Yeah. I never played around with it much. I rarely use that either. So
Yep. Yeah, same. The alternative to this is basically, going back to promises, or you never left promises, but you're just going back to the subscriber functions. Have your async function, right? Do whatever. This will return a promise, which you can then, even if there's no return statement, it still returns a promise. Okay. Just use, call the function dot catch with anything that you want to, with any code that you want to run in the event that an error occurs. Are there any questions? So I showed you like two methods of error handling with async/await. Okay. A hint for P1. Await promise.all. All your requests go here. Of course, right? Please don't put 100 lines of code in the promise.all. You will use a for loop, create a
So we need a for loop. You can just do a map.
or snap. Yeah, I mean both. Or map for each whatever, right?
Yeah.
Like the foundation of all those is it loops through the entire array.
Yeah.
So that map or whatever, convert all of the user informations, user IDs to a fetch, and then you would have an array of promises that you can then use await promise.all on, and then that would return the data that you want. Okay, and then because if you do it one by one, then things will get ridiculously slow. Okay, so make sure you do it both.
So we'll have Programming Summit 1 released on Wednesday, and we'll talk about it. Any other questions, comments, concerns about promises? Okay, great seeing you all. Thank you so much.